All right, let's go ahead and get started. Thank you everyone for joining us today on our webinar, Bare Metal Kubernetes as a Service, where we'll take a look at the requirements of operationalizing a Kubernetes from the eyes of an operator, and then we'll do a deep dive into how to make Bare Metal Kubernetes a reality. My name is Saad Malik, and I'm the CTO for Spectro Cloud, and I'll also be the host for this webinar. So joining me are two key guests, Joe Searcy, the staff engineer at T-Mobile, and Anton Smith, the product manager at Canonical. Joe, do you want to start off by saying some things about yourself?
Sure. Yeah, I'm a staff level engineer at T-Mobile, and for the past 5 or 6 years, I've been working in and around the Kubernetes project, helping T-Mobile build out our on-premise Kubernetes as a service platform. As well as the ecosystem that sits around and supports that to enable our internal development teams to deploy and build applications that help the business run.
And Anton?
Hi, I'm Anton Smith. I'm a product manager at Canonical. I'm working on Metal as a Service. Most of my career has been spent doing networking, so IP MPLS, carrier grade, infrastructure things. Building products, and got a real soft spot for bare metal actually, and edge computing, and love the intersection between Kubernetes and bare metal in particular.
Cool, and a little bit about myself, guys. Saad Malik, I'm the CTO and co-founder here at Spectro Cloud. I'm the guy who likes to build and tinker with new technologies, especially when it contains distributed systems, containers, virtualizations. At Spectro Cloud, we're really trying to make Kubernetes accessible to all organizations, really focusing on operating Kubernetes at scale. So thank you both. And before we get into the content, for everyone on the audience, if you have any questions, feel free to post them in the Zoom webinars question sections. As we go through the presentations, we can answer them, and time permitting, we'll also have a live question section answer at the end. So with that, Joe, do you want to get into your presentation?
Sure. 1 second here so I can manage the slides a little bit. All right, so before we get into too deep into talking about bare metal Kubernetes and all that great stuff, I want to talk a little bit about T-Mobile's journey and kind of how we even got to the point of looking at a platform like Kubernetes. And I promise I won't bore you too much. I'll try to make it quick. But essentially, going back several years ago, we were at a point to where it was taking about 7 months and over 72 different steps to take code and deploy it into production here at T-Mobile. And I think that information sort of speaks for itself and sets a fairly dim tone overall. We were sort of the underdog in the market, and we were really trying to do the right thing by our customers. We had super amazing leadership and incredible marketing minds that set out with the concept of things like our Uncarrier Move program. And that was quickly turning around things for us as a company in the telecom industry. We were starting to really hit friction, though, in what we needed to be competitive in the market and what we could really offer from a technology perspective. Our leadership really wanted to be at a point where we had the right agility to take an idea that started out at the beginning of the day and put that idea in production in the hands of our customers by the end of the day. And we just weren't in a place to be able to do that. Do something like try to give millions of customers free pizza on a whim, you'll start to see where your infrastructure and your technology stack will fall over. So it was sort of a wake-up call, and we really had to undergo a huge transformation to make something like that work. You can't just take your applications and shove them onto a platform like Kubernetes overnight. So it required a little bit of thought and a lot of effort. So we had a major cultural shift to sort of move to a microservices model for our application stack. And luckily, we had both top-down and bottom-up support to really empower us to make that happen, both on the infrastructure and platform side of the house, as well as our application development side of the house. So we started out with some other container platforms like Cloud Foundry and Mesosphere, and that got us started into the microservices space before ultimately arriving at Kubernetes as our standard platform for all new applications. And now I'm happy to be able to say that we're doing, dozens of production deployments every single day. And we just celebrated some of the best numbers in the company's history. And I think it's pretty safe to say that we rose to the challenge as a technology organization, and Kubernetes has definitely helped us get to where we are today. So going into, we've established this need of we need to be able to move fast, we need to be very agile, and we needed to really transform how we were looking at deploying code into production at T-Mobile. And we set out to build a Kubernetes platform, right? But before that happened, we were still seeing, or we started to see different Kubernetes bubbles pop up here and there around our organization. And some of that was manually rolled stuff here. We saw even some standalone Docker stuff. We saw some people reaching out and looking at some of the managed Kubernetes offerings on public cloud environments. And it was pretty much one-off stuff that mostly checked the "it works" box more so than the "it's production ready" box. And we decided that we wanted to take our expertise of building platforms like Cloud Foundry and apply that to Kubernetes. So since there was an obvious demand for Kubernetes, if we didn't provide the platform, our developers were obviously going to go out and try to solve that themselves. And we really wanted to make sure that we had a secure, scalable, and highly available Kubernetes platform with the proper ecosystem of tools so that our developers could kind of just focus on pushing code rather than worrying about life cycle of a platform and all the tool sets that come along with it. So that kind of brought us into looking at Kubernetes as a service at T-Mobile. And as we set out to build this platform, we had a lot of infrastructure experience to lean on from how we've been doing things around, bare metal systems and virtual machines. And while we do Kubernetes both on-premise and in public cloud at T-Mobile, I'm primarily going to be talking about what we've done in our data centers on-premise. So we set out to sort of model a lot of what we saw at public cloud providers with a multiple availability zone approach. And we really took to a shared nothing physical infrastructure approach to where each availability zone had its own separate compute, network, and storage. And then to sort of put it all together and make our lives a little bit easier, since back in 2016, rolling Kubernetes in your own data center was pretty challenging. We decided that we would virtualize a lot of our compute layers here to be able to give us the APIs to manage this as a true infrastructure as a service platform, and to be able to drive a lot of our platform builds and cluster builds for Kubernetes via automation. We really had an investment to the GitOps model early on, and it's been one of the biggest factors of how we've been able to reach the scale that we're at today with kind of a small group of engineers that we have. So we've gone from about 3 engineers in the early days to around 10, 12 folks today. But our environment has gone from a couple of Kubernetes clusters to over 150 Kubernetes clusters. So again, focusing in on how we build clusters and that GitOps model, it's fairly simple these days. We generate a fairly minimal amount of configuration to describe how the clusters get built. And we commit that out into a Git repository, and then it's sort of off to the races from there, and our tool set takes over. And obviously there's a lot of moving parts that happen between the time of committing, that configuration and getting a Kubernetes cluster out the other end. But all of that's handled by code and by our tool chain. And, we wouldn't be able to operate at our scale today without that sort of thing in play. All the pieces from managing the interaction with the IaaS layers and then also bootstrapping the Kubernetes bits, and then layering in all the things like ingress and persistent storage and logging and monitoring on top of it to really make it useful. And we've had different solutions over time. We started out with sort of building and rolling our own tools to bootstrap Kubernetes and the infrastructure, and then went into some vendor provided solutions, and ultimately we've landed on using the Kubernetes cluster API technology as part of Spectro Cloud's palette solution. And we really partnered with Spectro Cloud there to get us up and running fast to continue to maintain our velocity and see some of the enhancements that they made on top of the raw upstream cluster API solution. So as we sit today, we have a very flourishing internal Kubernetes community at T-Mobile. We have thousands of developers consuming our Kubernetes platform with somewhere north of 35,000 workloads running on our platform today. And a good chunk of what makes our business go is running on Kubernetes now. And I'm not talking about the sort of ephemeral web applications that a lot of people's mind goes to at first. We have systems of record, we have retail applications, billing applications, lots of our middleware environment, things like identity and fraud management workloads, and many others. You know, with the great success that we've had with our Kubernetes environment at T-Mobile, we have more and more workloads coming to the platform now. And a large portion of these fit right in with little to no effort, but we're starting to see sort of new variety of applications coming to the platform. And those aren't things that fit into what we offer today. They require something a bit beyond what we have in our virtualized environments. So this is things like artificial intelligence and machine learning workloads, you know, looking at establishing something like a machine learning as a service platform on top of our Kubernetes environment. Things that require access to GPUs to be able to reasonably compute, you know, the data sets at the size that we're looking at. And those things start to, you know, need additional performance and not have the overhead of a virtualization like hypervisor layer in there. Other things around like software-defined networking and moving some of the network functions on top of Kubernetes. These things can require specialized hardware in the form of like FPGAs or specialized network adapters. And that stuff's pretty difficult to do in a virtualized environment, let alone like before you get into stacking Kubernetes on top of it. And then things like database as a service, where we're really trying to you know, do more than just provision a database that runs on Kubernetes, but really build a rich platform that mirrors a lot of the offerings you see in public cloud providers in our data centers, since things like moving data to and from in and out of a public cloud environment is one of the most costly expenditures you can have these days. So it's not a super great feeling when we have our developers come to us and with their needs and we have to sort of turn them away because we don't have a solution to offer them that fits into some of these models. So, you know, we started looking at how we could offer some bare metal Kubernetes environments to augment what we already have and to continue meeting the demand of our user base. So that's new problems to solve. And you know, it brings up questions in like, how can we even do this when we have like a lot of our mobility, agility, and velocity is built around like utilizing these existing tool chains that we have. And from our perspective, there's sort of two main challenges in being able to offer bare metal Kubernetes in our environment. The first being, how the heck do we get to where we can treat bare metal machines like an IaaS layer that can be driven via APIs? And then the second one is, you know, how do we begin to bootstrap Kubernetes on top of bare metal? It's a little bit different of a beast. And we don't really want to have a completely separate tool chain for bare metal. We don't want to get into the pattern of like having to have a new tool chain for every different flavor or variety or shape of Kubernetes out there. And we really aren't staffed to add a whole new tool chain for that. And we're not in a position to slow down either. So we have to continue to deliver clusters in a timely fashion and ideally with no additional operational overhead in a way that can be governed inside, you know, our standard policy and guardrails that we have in place, and that's compatible with our existing workflows. So ultimately, we want all the benefits of bare metal, and we want to treat it exactly the same as we have our virtualized environments. But that's sort of tough. And there are definitely tools out there like Canonical's MAAS service that can bridge that gap. So Anton, do you think you could give us a little better idea of how MAAS can help with some of these issues?
I can certainly try. Let me just take control of the slides. Okay, great. So yeah, it sounds like you're trying to do a lot, and you basically have two problems here. One is how do you manage bare metal infrastructure as a service in an infrastructure as a service manner? How do you turn all that complexity into an API? Because machines have a lot of like details about them. They have firmware, they have sort of RAID configurations, they have different types of hardware accelerators. So I'll get into that, and then I think there's also the integrated Kubernetes management side of things that Saad is going to cover after me. So if I tap right, hey, Saad, can you move? Oh, hang on, there we go. All right. So when I started my career, it was in telecoms as well. I didn't have a beard back then though, so I didn't know so much. But one of my first roles was doing testing, and we had a lab. It was for Telecom New Zealand, so for the carrier network. And I still remember how long it took us to build a radius server from the ground up. We'd get like an old, some kind of Sun machine, and would have to like create this really long method of procedure about how to install the operating system, how to configure the RAID and stuff that I just mentioned, install free radius or whatever it was that we were using, and also setting up the database. This process took like 2 or 3 engineers, and please no jokes about how good the engineers were, but it took 2 or 3 of us for, like a month if you take into account all the testing and everything that we needed to do, because the entire carrier grade like broadband service was dependent on these machines and their configuration. So we've really come a long way in that time until now, where we can sort of start to programmatically configure machines. Now, Joe, I was going to ask you, do you enjoy running? Because in your data centers, I can't remember, was it 53,000 CPUs? I guess you've got a lot of machines. Now, take what I was just talking about to like build one radius server, and then imagine that you have to go around your 53K worth of CPUs and get an operating system on those machines with this little USB stick.
Yeah, I can't figure out the right command to distribute the USB drive through our data center in like a Git workflow. So
no, right. Unless it was like send an email to your coworkers. So, this is clearly a challenge, taking into account all of the things that you need to do to get a machine up and running. Okay, so on the left-hand side, you've got AWS. Like this is like something that we're all used to today, right? It's become a really normal thing. And just keep that in the back of your mind as well, what I mentioned about figuring out how to get a machine up and running in the old days. Nowadays, it's like a few commands like this in a software SDK, Python, or in the console for the cloud providers. And you can literally spin up like 100 machines, 1,000 machines, virtual machines, most likely. On the right-hand side, you've got a new machine, or you request a new machine that needs to come online. Maybe you want to add it to your Kubernetes cluster. First, you have to like request the machine, put in a purchase order. By the way, there could have already been another machine sitting in the rack ready to go, but somebody else kind of owned it and it wasn't centrally managed by any type of system. So you had to order a new one. Someone has to go and rack it. They have to update the firmware. There might be multiple firmwares in the machine. It's not just the BIOS for the machine. It could be some of the controllers and stuff as well. Disk encryption, RAID configuration, like kernel options, installing the operating system, launching it, setting up credentials, and then doing automation only at the very tail end of that. And credentials, by the way, also super important that that's done in a secure way, and there's not very much room for intervention by, say, bad actors, meaning people in your data center that have physical access to your machines. It's better to not have to deal with that. So this means that doing it with bare metal yourself presents a number of challenges.
Not just, imagine if not doing it just for one machine, but multiple machines, 10,
yeah, right.
100, thousands, right? What would it look like?
Right, exactly. So then scale that out. How do I can't get it to go to the next slide.
Yeah, move next. There we go.
There we go. Okay, so according to us, you're looking at about 4 minutes versus 4 months, which is quite a really big number. There's actually a great presentation by one of Joe's colleagues called Joshua, where he talks about this exact process. And we really want to bring this down. There's no need for this to be 4 months, actually. If you think about what the public cloud providers and others who are running cloud are doing, they have some tooling, some internal tooling that they're using to enable you to get machines within 4 minutes. Now, granted, they're probably virtual machines, but with bare metal, you can get it down pretty close to that as well.
Thanks.
There we go. Okay, so what do we want? We want to be a cloud. Like we're, Joe and others, and some of you on the call, you're building clouds. You're not using public cloud, or maybe you are, but you also want to have your own cloud, like in a hybrid or multi-cloud scenario. You want all the good stuff. You want automation. You want everything as an API. You want to support diverse substrates because you're building the cloud, and that means that you need to care about those substrates. And you want the economics to be there as well. Like it's never going to work at scale with, say, 53K CPU cores for you to do things the old way. It's just not going to work. But you also need to celebrate metal, right? Like there's no getting away from the physicality of the machines that you have to look after, even if you homogenize them. And I thought there was something very interesting that you brought up before, Joe, was about new types of workloads. So things that require GPUs, things that require FPGAs, or any other kind of hardware that you need in order to bring those new workloads on board. And yet, not all workloads have a good affinity for all types of hardware. So you really want, you don't want to take 8 cores from a machine that has a big GPU in it and give that to somebody who only wanted the CPU cores. You want to maximize the utilization of the hardware that you have out there, including in a heterogeneous environment. And it needs to be heterogeneous because you have these new use cases coming. Now, to really celebrate metal, you should be multi-vendor, and meaning that it doesn't matter if it's Dell or HP or some kind of white boxes. You want to support multiple architectures, like ARM64 is a big thing, maybe RISC-V in the future, x86. You want to be OS neutral, so you can deploy any kind of operating system, any of the major operating systems. And also, as I mentioned at the beginning, enhanced platform awareness. This basically means celebrating metal. It means you know what's in those machines, you know how to inventory it, you know how to test it, and you know how to present that in a sensible way through programmatic interfaces like APIs, so it can be consumed and then used in a smart way. So Canonical MAAS offers a lot of that, and that's the driver for what we do. Canonical MAAS is an open source project. We're really happy that people are using it and plugging it into Kubernetes with the cluster API. For me, this is a perfect thing to do with it. It's what it's designed to do, to be plugged into different types of systems. We think it's the most popular free solution for managing and orchestrating bare metal. We do celebrate metal, absolutely. We're multi-vendor, Cisco, Dell, HP, Supermicro, even mainframe. Some mainframe stuff is in there. Some power stuff is supported. Lots of different drivers for out-of-band power control, like different types of BMCs, and also a lot of automation with the very rich API, Python SDK, and we're trying to add more operating systems as we go, as well as scaling for a number of machines. Like we understand that the economics of something like this get much better when you're able to scale your control platforms to tens of thousands of servers. So with that, I think we've got the bare metal as a service part covered. Now we need to figure out how to connect it to Kubernetes, right?
Yep, absolutely. Thank you, Anton. And Anton, I believe Canonical MAAS is one of the most mature platforms when it comes to bare metal management interface. I think it's been around for around 12 years now, and you have support for, I think, 20 plus different power drivers. So any type of hardware you want to be able to bring in, you're able to support. And of course, you also do have support for Redfish and IPMI. So you have limitless support for any solution you want to bring in, which is fantastic.
Sounds like you know it better than I do. Actually, you remind me of a couple of things there, because you could also say like, okay, why don't we just use, say, some Pixie tools off the shelf and strap together a bunch of scripts and so on. But I think maybe because of the age of MAAS, in a good way, age, like, hey, I'm getting old and I think it's just
Wine.
good. If I can find wine, thank you. We've learned a lot of lessons along the way, right? Like, it's not just about being able to boot machines and install an operating system. It's also like, well, hey, what about testing? What if I want to like systematically test the hardware in every single server that gets brought online? And every time I treat it, by the way, like as a code like resource, I can retest it again. So if I'm blowing away the operating system, and I'm gonna like run a whole, CI/CD pipeline to push something down again, I'm going to test it in the middle. I'm just going to check the memory's good, the hard drive's good, the CPUs are working okay, so therefore the cooling must be okay, as well as your own custom test that you can add in there, which means that you can feel, more comfortable knowing that your fleet is healthy. And I think that it's that kind of lesson is something that you get over time.
Yeah, I think one of the other things that comes along with this type of capabilities is at a certain scale, being able to transition the mindset away from thinking about building servers on like a server by server case to more of like provisioning a rack, and thinking about compute in terms of racks versus just individual servers and things like that, because you do truly have the tools that can help you manage the scale versus relying on people and USB sticks and things like that to manage.
Yeah.
Cool. All right, guys. So let's talk about the Kubernetes angle into it. So traditionally, what we found in talking to our customers, one of the biggest challenges with managing bare metal Kubernetes is the disconnect between the operating system and managing the Kubernetes, which is on top. Right? In most cases, there are different sets of users, different sets of operators when it comes to managing and provisioning and upgrading these different environments, different layers. And because they have different life cycles, different users and operators that are managing the operating system versus the Kubernetes and even the server aspect, it can definitely lead to inconsistencies and incompatibility between the various layers. And obviously, this can ultimately affect your cluster availability, right? It can reduce it. And at the same time, any applications which are running on these clusters would, of course, be impacted. Now, I think Canonical MAAS, and you, Anton, you've heard me say this before, I think it's a fantastic product in that it's able to bridge that gap between these machines, the servers, and the operating system. The whole aspect of being able to manage a bare metal machine with a simple programmatic APIs really allows server admins and operators with a single click, or in the case for developers and DevOps, with a single press of a key, manage these systems, whether it's one bare metal systems or hundreds of them, at scale. It provides, like you both mentioned, the cloud-like experience that allows us to provision, upgrade, manage, deprovision heterogeneous type of resources and as an abstraction. So I don't have to look at specifically for this bare metal system, how do I do operations, how do I use IPMI, how do I use Redfish or the UCS APIs. And to your actual picture that you had of the thousands of bare metal servers, I definitely don't want to be the guy with a USB stick that's running in and updating one by one. It just doesn't scale at all. So now that obviously,
so do you mean you don't want to be on the end of the CI/CD pipeline from Joe?
I mean, if Joe can clone me and make 1 million copies of me, sure, Joe, go for it. So in this case, now if we do have the operating system and the server being managed by MAAS, right? What about the Kubernetes layer that sits on top, right? This is where Spectro Cloud really comes in, because what we have built is a commercial offering called the Spectro Cloud Palette, which helps IT operations and platform engineering teams and even developers to deploy and manage production-grade Kubernetes clusters with ease. So our platform itself is, of course, built with awesome open source technologies, whether it's Kubernetes, any of the integrations. But one of the key components that we use in Palette is Cluster API. So Cluster API is a very popular Kubernetes orchestration tool It's governed by the cluster lifecycles SIG. It's a special interest group. It has a massive community and a lot of vendor adoption. In fact, if you take a look at the most modern Kubernetes management platforms, from VMware, Tanzu to Google Anthos, and of course Spectro Cloud, we all utilize Cluster API for its ability to cohesively manage clusters across many different environments. Now, what sets Cluster API apart from other tools is its declarative approach, right? To being able to manage the lifecycle of Kubernetes clusters. The key that Cluster API does that's unique for across most of the orchestration tools is that it also provisions the underlying infrastructure. Now, whether it deals with the actual compute, the VMs or bare metals, it also provisions the storage, it also provisions the networking. And because it manages all this infra together, you also gain out-of-the-box capabilities like resiliency and error recovery, right? I'll give an example here. Imagine that if you actually have a cluster that is up and running that has 3 actual bare metal systems, if one of the bare metal nodes becomes unhealthy, right, middle of the night, 3 o'clock, are you gonna call the clone Saad and be like, hey, guy, go set up another server, plug in the USB stick? Or would you programmatically have the system automatically detect that one of the nodes is unhealthy and let me replace it, let it automatically replace it by itself? Even day 2 capabilities like scaling operations, whether you're scaling additional nodes, you're adding additional node pools, all of this is possible because Cluster API manages the infra as well as the operational aspect of initializing Kubernetes and joining nodes into the Kubernetes cluster. So the way Cluster API is built is using a really cool plugin architecture called providers, which allows vendors and operators to add support for the favorite cloud or environment. Whether it's adding support for Amazon, Google, Azure, or private clouds like vSphere and OpenStack, right? It's just very easy to be able to have a plugin to say, you go ahead and provision using EC2 API calls versus make a call into vCenter to clone on new machines. And so this provider is the implementation that allows the Cluster API to talk to various endpoints, whether bare metal or VMs for the Kubernetes management.
Someone's at the front door doorbell.
So I think that it was very interesting what you said about servers, needing to be replaced. It made me think also about elasticity. I mean, you could end up with certain different organizations within you using your data center, like internal or external, and maybe they've got their own Kubernetes clusters. Maybe some of them are like can shrink and others can expand to utilize that bare metal that you have there. So it also allows you to be more dynamic.
Absolutely, right. I mean, there's so many awesome projects within Kubernetes like Cluster Autoscaler, which looks at the load of your pods, of your application, and then can dynamically say, I need to have more elasticity, or 80% of your cluster is not used at all. Do you really need to have these 8 of your VMs or 8 of your servers still running? We're using a programmatic aspect of whether it's bare metal or on the cloud, you can make those choices and have it dynamically scale as needed. So,
yeah, I think one of the other interesting things too, when you start talking about some of these workloads where your Kubernetes worker nodes might have things like GPUs or FPGAs that your cost per node is going to be a lot higher than provisioning out a virtual machine or something like that, where Cluster API, and its abstraction model with the different machine pools, gives you the ability to say maybe provision your control plane to be virtualized, but your worker nodes are, bare metal machines with GPUs exposed. So there's a lot of flexibility that it offers there.
Yeah, and absolutely. I think even part of the demo that Anton and I will do, we can show that you can tag whether those actual servers are GPU, whether they come from a different resource pool, or even potentially different racks with availability zones. And being able to tie that even across different environments, I think is just another level of capabilities that operators now have in their toolbox. So, plus, we all know Canonical MAAS has some fantastic APIs, whether it's to dynamically allocate machines that are a certain CPU or GPU or memory, and then of course being able to deploy the actual machines and then really manage the end-to-end lifecycle of these servers. So how do we connect Palette and Cluster API and MAAS? Well, that's where our team at Spectro Cloud built a new Cluster API provider called Cluster API MAAS. It's an open source project which anyone can use to provision Kubernetes clusters in their own data center, and obviously leveraging Canonical MAAS. It's again using the MAAS APIs to allocate machines of specific tags or configuration, and then deploys the machines, and using Cloud Init initializes the end-to-end Kubernetes. And as the operations come to say, I want to do a scaling operation, or one of the nodes has an error, the kubelet isn't starting for any reason, Cluster API can automatically detect that that node is unhealthy, and within minutes replace it with a brand new one. So with this, you now connect all the pieces, right? Where Palette with Cluster API and MAAS can provision end-to-end bare metal clusters. I think the key here is that now your bare metal Kubernetes clusters has the exact same experience as if you're managing a Kubernetes cluster on the public cloud or even a private cloud, with the same operation, with the same model saying, I want a 3-node control plane, 6-node workers with GPU and general purpose hardware, provision end-to-end cluster, being able to manage not only the operating system, the Kubernetes, but even the applications that sit on top of it, the same ease of use. And so with that, Joe, I think we've kind of done a job done where we now have an ability to provision bare metals using an IaaS, and then also tie it in with being able to provision end-to-end Kubernetes clusters. Do you guys think we should do a quick demo? Let's get into that.
Yeah, I think talking about stuff is fun, but seeing it work in the real world is more fun.
Awesome, awesome, awesome.
Yeah, just before you get started, we got a quick question I just wanted to answer. Kashif says, can't Juju be used for lifecycle management of K8s cluster once nodes are commissioned into MAAS? MAAS is open for usage by anybody, including ourselves with Juju or Spectro Cloud. So, you know, today we're talking about Spectro Cloud with MAAS, and but of course Juju is also out there. So I hope that answers that.
Absolutely. I'm going to start off my actual demo by talking a little bit about the MAAS product itself. So this MAAS is running in our own data center that's in a colo. I have 47 different machines of different types. Most are super micro, some are actual Dell systems. And in MAAS, you can very quickly see at a glance all the machines that are running, what are the states, you know, are they in ready states, are some allocated and ready to be deployed versus the ones that are actually fully deployed. MAAS has a really cool enlistment process where it can automatically detect new machines being added into the data center. And as part of that enlistment process, it can detect the number of CPUs, the memory, the storage disk configuration, even the networking interface cards. Now, using the UI or using their APIs, I can even specify things like, hey, I detected these 4 disks. How do you want to partition them? Do you want all the disks to be combined together with a single LVM? Do you want us to be able to have different formatting, you know, FS versus ext4 partition sizes? All that could be configured before you even deploy an actual system. And I think, Anton, you kind of covered a little bit on this commissioning process where not only do you have out-of-the-box commissioning test that runs that verifies is the CPU healthy, is the memory good, is the storage good, but I believe you even allow customers to add their additional commissioning tests so they can do their own verifications. Right. And then, of course, the operations that you can do directly for MAAS, I can click on take action, and I can say deploy. During the deploy aspect, I can specify which operating system do I want to deploy onto this bare metal system. I can pick a specific Ubuntu, you know, any of the ones that Canonical provides out of the box. But they do also have a very powerful image library where I can specify, I want to bring in my own operating system that has my own security hardened version of Ubuntu with FIPS enabled. So I can specify any release, any Ubuntu operating system, even inject a Cloud Init script. And then when I click on deploy, obviously at this point in time, it will use the whatever power driver you have configured. Is it IPIMI based? Is it UCS driver? Is it Redfish? To power on the system itself, and then using Pixie Boot, using the ephemeral operating system, install whatever operating system you specified. Just real quickly on the image. Yeah, please.
No, that's absolutely right. And also the API that you mentioned is behind this web interface. So we have a web interface that we've built utilizing the same API that Saad's using with Palette.
Yep, yep. And then on the images tab here, right, I can even take a look at the images that are synchronized automatically to all the Ubuntu ones, but I can also upload my own custom images. Again, whether it's Ubuntu, CentOS, Red Hat Enterprise Linux, all of them are supported in here. And Anton, do you support Windows as well, or is it on the plan?
We actually do support Windows, believe it or not. We strive to support as many operating systems as we can.
Cool. And then the last couple things I could show, and again, Anton could do a much better deep dive demo into MAAS if you have specific questions, but they also do manage the IP addresses. So in my environment, I actually have two network interfaces. One interface deals with talking to the BMC port of all the machines, but then the other interface is the actual data port where it has the actual IP addresses and DHCP. I can go into one of the subnets and even see what are the actual IPs that are going to be managed via MAAS, all the way down to which IPs are reserved for my own internal use versus which are used for my initial booting process, where I can get an internal ephemeral IP address. So all of this is visible from the MAAS interface or using their UIs. Now, how does this tie into Spectro Cloud Palette? So if I log into my Palette platform, let me zoom out a little bit. As I log in, I get logged in using single sign-on, right? Whether it's Okta-based or Azure AD, I get logged into a project in Spectro Cloud Palette. So projects in Palette, you can think of it like a multi-tenancy, where different users of different teams may have different requirements, whether they want clusters that are GPU or whether they want clusters that are public cloud. So you can separate different teams and applications into different projects. As a high-level user, I get visibility in terms of all the compute clusters that are running, not only in terms of the infrastructure cost, but even down into the namespace level. If I switch into the clusters view, here are a number of different clusters running in Palette, everything from Google to Azure to even MAAS clusters, and you get full visibility from a single pane of glass in terms of what's running, how many nodes, the CPU and memory. And if any of the clusters has an unhealthy node or unhealthy cluster, those even get notifications that are sent to your Slack channels or WebEx Teams channels. What we're going to do next is kind of show how Spectro Cloud is able to manage clusters at scale. And that concept is what we call a cluster profile. If I jump into a cluster profile like this MAAS demo prod 2, notice that it captures all the layers from your operating system to the Kubernetes to the networking and storage. These are what we call the core layers, and anything that sits on top of it, like the load balancers, Prometheus, Service Mesh, more, are the add-on layers. Using Palette, you can very easily add any integration that sits on top. Out of the box, we have support for around 40 or 50 different integrations across the different layers. But obviously, most customers, if they have their own Helm charts, have their own applications, they can very quickly also model it into this cluster profile. For the time being, we can add maybe an ingress from the public repository of maybe type nginx at the latest version. I can click on confirm and create. And as I click on save changes, right, obviously the update is now to the cluster profile. I can now deploy a cluster using this cluster profile directly. If I switch back to the clusters view and then click on, and before I actually deploy a cluster, I want to just show what is the link between Palette and MAAS. In the project settings, under cloud accounts, we can add cloud accounts for different cloud endpoints. Obviously, the public clouds like Amazon, Azure, Google have their own cloud accounts, but now in Palette, you can also add a cloud account for your MAAS endpoint. So here I can specify, what is my actual connection URL, what is my API key, and this is what we'll use in Palette and Cluster API to provision end-to-end machines, and on top of it, initialize the Kubernetes layers. If I go back to clusters now, click on create, I can specify MAAS demo 6. I can select next. We can pick the cluster profile that we just modified, the MAAS demo prod 2. And again, we added an nginx layer that sits on top of it. And then if I need to make any customizations, I can do that. For now, I'll click on next. We select the cloud account and then select the DNS domain that this cluster will have. So I can pick the maas.sc DNS domain. And then for the pool configuration, I can say, I want to launch 3 master nodes. And maybe to Joe's point, he says, I don't want the masters to be running GPU workloads. It doesn't make any sense. They don't have to be super beefy. We can just take generic compute servers available from MAAS and go ahead and deploy them across my AZ1, AZ2, and AZ3. For my worker pool, maybe my generic one, I can do the exact same thing. I have a single node that comes from my medium generic pool, maybe from AZ1, but your additional node pool, maybe you have some GPU workloads that you want to taint those pools. Click on add new pool, and they can specify GPU pool 1. And I can say I want 3 nodes coming from my GPU. The resource pool that I'm provisioning from is bare metal GPU. And again, I want them distributed across multiple racks. I mean, again, Anton, I'm sure in your use cases, AZs could be racks, it could be data centers, it could be buildings, it could be anything essentially, right?
You can basically define it how you like. So that's right.
Cool. Saad, before you jump on, I'm sitting here watching this little estimated rate counter click up as you're clicking around and changing different things there. Now, I'm used to seeing a kind of cost analysis for public cloud resources. How does that work with bare metal?
Great question. On the public cloud side, we directly access the APIs of the public clouds to get the instance types and the updated instance rate. That's an updated basis. For private clouds, whether it's vCenter, OpenStack, or MAAS now, obviously what a bare metal cost to you might be very different. What the actual instance or infrastructure cost to you is different. In the admin level settings, you can specify for your own administration what 1 CPU core costs you and what 1 GB of memory costs you. And that way you can do your own internal show back and charge back and even assign quotas per project. That project default has access to $10,000 a month, whereas process production has access to $20,000 a month. So even for internal and private clouds, you can do your internal show back and charge back and governance around that.
I mean, you could even work with your finance department to figure out depreciation costs and so on and put it in there if you want, right?
Absolutely, yeah, exactly. On the next screen, so more than just provisioning clusters, with palettes that goes beyond cluster API are things like upgrading the operating system, whether you want to schedule this to be done on a nightly basis. You can do things like scanning. And obviously, security is fundamental to any operators that's operating Kubernetes. Here, we let users do conformance scans, security scans, even penetration scan testing. And business continuity, right? Being able to back up all the resources, all the disks that are running in the cluster, most likely do this on a nightly basis and back it up to an S3 compatible location. And then, of course, there's other capabilities like RBAC management, quota control. All that can also be specified through the palette UI or through the automation. If I click on validate, make sure everything looks good, and then click on deploy. So at this point in time, palette through cluster API will talk to MAAS, begin provisioning of an end-to-end cluster with the configuration that you specified. And this, I won't take too much longer on the demo, but just real quickly, I can jump into an existing MAAS cluster that was provisioned a couple of months ago. Again, you can see the level of health, the fact that it's running, the version of Kubernetes, anything that's running in the cluster itself, all the way from the workloads and namespaces, you get full visibility. And like we talked, and we're going to be talking about is day 2 operations, things like scaling operation. I want to scale my master nodes or my worker nodes. It's as simple as clicking a button and saying, here's a new estimated cost. Are you okay? Boom, start provisioning the new nodes.
So is it possible to see those machines deploying in MAAS, or is that?
It is absolutely. No, for sure. It's the same as itself. So within a few seconds or probably 30 seconds or so, you'll see a machine that goes from ready into allocating and deploying. And then that whole process will be fully automated directly from the UI. Cool. That's the end of the demo, guys. Let me share my screen again. This time, desktop 2. And then we can. So you mentioned some requirements for bare metal Kubernetes clusters, why they're important to T-Mobile and your team. Anton, maybe can you also add a little bit about the benefits, the primary use cases for where you see customers running bare metal Kubernetes?
Yeah, I mean, you've got 3 big ones here: improved performance, like stripping out the hypervisor, for example, making it simpler. Joe mentioned, deploying GPUs and FPGAs, for example, that can be tricky with virtualization. So we see people looking for simplicity. I think there's also a few scary things that have happened. Like I think yesterday I saw something about vulnerabilities in ESXi that were enabling people to basically leak information between VMs. So you never know when anything like that is going to happen with security. So if you want to get the ultimate level of security, then you have single tenancy. So you're the only one on the machine, and you're also not subject to things like Spectre and other things. That also means you can turn off those fixes that Intel and AMD released that basically sacrifice performance for security. So I think that's a really big thing, and I think it's maybe keeping alive, really very much bringing back alive this discussion about performance. So there's an interplay there between performance and security. And then, of course, cost. I mean, you can start to treat machines like, the Kubernetes infrastructure API, or the API for Kubernetes becomes your way of doing multi-tenancy as well, if you're not worried about those security things, of course, that I just mentioned. But it shares those security concerns with VMs. However, it does mean that you don't have to have the hypervisor there or the hypervisor tags.
Yeah, absolutely. And then also, if you think about containers with Kubernetes, Kubernetes provides an awesome abstraction, whether it's over your compute, your storage, networking. And in many ways, your virtualized environments like vSphere and OpenStack provide the exact same layer. Do you really need another layer of fat if you're already building containerized applications? Most likely not.
It's another thing to manage, right?
Another thing to manage, another thing to support, another thing to train your operations teams, your platform engineering teams. It's not needed, right? And I do believe, obviously, we'll start off initially with the use cases that are with high performance computing or data science workloads because they need that extra performance. But over time, as more and more organizations are only building cloud native applications, only building containers, I think we're going to start seeing even more bare metal direct Kubernetes clusters, especially if the experience of managing it is as similar or even faster than having a hypervisor layer in the middle.
Yeah, I think that's a good key point, Saad, that you mentioned. I think the barrier to entry, that it's been in the past of just managing the machines themselves, but then also like worrying about all the other bits that stack on top of it, has prevented a lot of people from looking at it and given the feeling that a hypervisor is required for Kubernetes, or it's the only way. So I think having tools like this out there, and can't say enough about having a tool like Cluster API in the mix of all this that like has that pluggable interface to where the next cloud provider or infrastructure provider that comes out, like it can plug right in, and all of the investment that you've made into your tool chain and your workflows for how you and your environment manage your Kubernetes platform, you're able to just keep running. Like you don't have to slow down, stop, and solve that problem and wait to get back up to speed with where you were already at. And that's where like something else that you mentioned earlier, and I feel like you sort of glossed over some of the magic with Palette there, and that like my clicking finger was getting tired watching you go through the interface there, but that's all driven by APIs, right?
Absolutely.
Yeah, so that's where again when you make that transition from like a couple of Kubernetes clusters to having dozens or hundreds of Kubernetes clusters, having a model like the GitOps flow that we have at T-Mobile, where we can commit a config, and a few minutes later a cluster comes out the other end, and whether that's a virtualized public cloud or a bare metal cluster, like it can all be driven in a similar fashion. So I think that's a huge tool to get people into managing Kubernetes on their own without having to necessarily depend on a GKE or an AKS or something like that.
Yeah, no, absolutely. And I think it's vital. But once you get past 5 clusters, just the exact same reason you don't want to be that intern or that Saad in the data center plugging in USB sticks one by each other. You don't want to be the Saad that's clicking and provisioning cluster after cluster after cluster, right? It just doesn't scale. Being able to have a GitOps workflow the way you guys have done at T-Mobile is just fantastic. And obviously from your perspective, it's not just about bringing up the clusters themselves and the actual applications, but all the various integrations that go into it, from your authentication into how you guys authenticate with your Okta into the cluster, your CI/CD workflow for your application teams, for your infra teams, all the way to your auditing, alerting, monitoring. Everything has to come together as a single unit. And the only way this is going to be done at scale is through automation. So you're absolutely right, Joe. We do obviously have a very popular Terraform provider. It has over 2 million downloads as of right now. And your team and many other organizations around that use Spectro Cloud are leveraging it to manage the cluster profiles and the clusters themselves, at scale. One more thing that I want to just touch up, and I would love to get your guys' input. So when we look at modeling and provisioning of clusters, these are obviously day 0 and day 1 tasks. Whether you're provisioning a cluster into Canonical MAAS or on-premise data center like vSphere or even a public cloud. However, I think majority of complexities and challenges that teams face come when dealing with day 2 operations. Because let's face it, business requirements and application requirements, they're constantly changing. Whether it's my manager saying, yeah, what about this? This competitor to XYZ, can we also copy that? Can we do something better than that? So these requirements will ultimately drive additional technology changes, whether it's the cluster level application changes, like I need to have a new logging solution, let's bring in a new service mesh solution, let's do business continuity, let's do backup restore. So obviously in our view, there are so many different aspects that come to tooling and operations that operators and platform engineers like Joe and his team have to worry about. What are your thoughts on some of the day 2 operations that Kubernetes, specifically also with bare metal, that also have to be brought in and thought about as operators?
Yeah, we started out like a lot of organizations probably did in the very early days of Kubernetes with, we can boot up a system, install an operating system, and write some scripts and things to automate installing the kubelet and kubeproxy and different things like that, and lean on things like kubeadm to join all the nodes together and build a cluster. But that's not really sustainable, in any way, shape, or form. And all of that can kind of, fall apart when you need to upgrade your Kubernetes version or upgrade your operating system. And there's this, compatibility matrix of, do I have the right firmware here and the right version of the hypervisor, the right kernel level, and then the right kubelet, and so on and so forth. There's a lot to worry about. And we always joke, in the Kubernetes like cluster lifecycle environment, take something like certificate management, like rotating a certificates so that, all the communication between your nodes is secure, and your worker nodes and your API server is secured, and like etcd is secured. Like keeping track of all of those different like touch points and, knowing when those things expire and how to rotate them, and doing that online, it's like trying to change a tire while you're driving, 80 miles an hour down the interstate, So I think there's a lot of the day 2 operational side of things that can really sort of stunt Kubernetes adoption in an organization. It's tough, luckily we have awesome tools like this, and cluster API and MAAS for managing the bare metal layers, and it takes a lot of those headaches away, ultimately making something like Kubernetes much easier to achieve in your own data centers, or in hybrid environments where you're leaning on the public clouds, but also on your own data centers. And I think anything you can do to make it easier is ultimately more time you can spend, building your business and focusing on, business logic and your applications and the services that you're offering to customers. So huge benefit for solving probably one of the hardest problems, which is, it's never, can I get it up running and working? It's keeping it up running and working, and then like making sure it stays secure and up to date.
Absolutely. All right, cool. Any questions that we have? So the only question, yeah, please.
There was one that I answered, but maybe incorrectly, so it's maybe better if you answer it. Kashish says, which CNI are you using? Yeah.
Yep.
Can you?
And your answer is absolutely correct. So we have support for multiple different types of CNIs. And as part of the cluster profile, we didn't get a chance to fully build a new one, but for each of the different layers that you go through, your operating system, your Kubernetes, your storage, your networking, we provide many out-of-the-box options. For CNI specifically, we support Calico, Cilium, Flannel, WeaveNet, Hermana, and we're looking at adding multi-support. So if you want to be able to have multiple different CNIs together, that some pods need specific CNI, another one is another one, we can also support that too. If there are specific other requirements that you have about bringing your own CNI, please come to us. We're happy to add it. But in that private repository aspect, even if we don't support it out of the box, you can upload your own integration and model it as part of the cluster profile. And whether that's a network layer, the application layer, or even the OS layer, if you have your own security hardened Ubuntu or your SUSE Linux that you want to bring in, you can even model those in your private repositories and model it.
It looks like we have another question from John, and I'll take a stab at answering this. Just to repeat the question here, it's like John's at a company that did a push to sort of the public cloud, referencing things like cost of running bare metal and the overhead of maintaining hardware and software in the data center. And the question is, like, aside from all the great reasons to use MAAS and Palette, how would I convince them this is possibly the right move to go back to bare metal? And that's kind of a twofold question, and I'll take my best stab at it. But I think these days that, each organization sort of faced with that challenge of, is the public cloud the right space for me? Is my own data center the right space? And we've seen a lot of opinions sort of change over the past decade in IT. Especially in big business, a big enterprise. And there's no one size fits all for that. For a lot of groups, there's a lot to be said about the velocity that you can get with jumping onto a public cloud and having, essentially unlimited resources, as long as your checks, cash, at your fingertips, having all of the different pieces being driven with APIs. So speed can equal money, in those senses of how fast it takes you to get up and running, how long it takes you to deliver, some piece of technology that supports the services you offer your customers. So no one size fits all question there. If you're a business that already has data centers and it's been a complexity or velocity challenge to bring something like Kubernetes into those data centers, the story changes a little bit, because I do think tools like this get the barriers to entry out of the way to the highest degree, to where you can really close the gap between what you can do in your own data center versus what you can have in a public cloud provider. There's still a lot of stuff like DNS and load balancers and databases and things like that again, in a public cloud you can click a button or run some Terraform and have those at your fingertip. And it's a big investment of time to mirror those same features and functionality in your own data center. So it's a tough thing. If it's something you feel passionate about, always reach out, and happy to help you shape some of those conversations as best as possible.
And then we have one question for Anton.
Yeah.
Yeah, go for it.
By the way, John, just to comment, but I'm sure you've seen Silicon Valley with Giles. He had this. He had his own bare metal in the garage, and when he had to unpack it all and move to the cloud, and he was quite sad. That was a very touching moment for somebody like me. Anyway, so how does MAAS handle different types of metal nodes in detail, and how does it load balance across same metal types like FPGA or GPU? So this one is a bit of a nuanced answer. I think Saad's going to have to help me out here as well. But what MAAS does is it enables you to automatically tag machines based on what are called XPath expressions. So that means that you can essentially tag machines automatically based off any hardware configuration that you can come up with. And at the same time, it supports some special tags that allow you to deploy kernel options, so that when you deploy the machine, those kernel options, like during boot, the grub will be configured. So for example, many of you have probably configured kernel options for NVIDIA GPUs that you want to pass through to a VM, and you know that it's quite tricky. And then imagine that you have to do that for 1,000 machines. So MAAS can do that automatically for you. But having these tags, you might have noticed in Palette that those tags were kind of being represented there. And I think, Saad, maybe you can speak to how you might load balance workloads across different hardware types?
Yeah, great question. So Anton's absolutely right. So in Palette itself, when we are making a node pool, you specify which machines do you want to allocate for a MAAS? Because MAAS obviously has three different variations of being able to specify what a machine is. The most simplest one is that resource pool, where I can define a resource pool could be an instance type. You know, I want my medium general purpose compute hardware to be medium pool. I have my GPU nodes or GPU appliances or GPU servers in the GPU pool. And then you can separate them across different availability zones. And the third aspect is these tags. All these three various ways of classifying different servers from the Palette UI, from the Palette Terraform providers, you can specify how you're supposed to select them and how you're supposed to deploy them end to end. Load balancing across these different middle machines, in the case for the actual control plane nodes, is done via DNS load balancing that MAAS provides. So when we provision a single bare metal system itself, we actually also create a DNS entry inside of MAAS that says for my cluster 1, this is my address for my control plane node. As you are now adding additional bare metal servers that act as control plane nodes, we will just update the DNS entries in MAAS so that now you have full round robin across all your bare metal systems from the control. Cool, I think that's good, guys. I think we can wrap up our bare metal Kubernetes as a service webinar. Please do visit the MAAS website, maas.io, and check out the resources page. Anton wrote a really comprehensive white paper which discusses MAAS, cluster API, bare metal Kubernetes in detail. Highly recommend whoever's left, please read it. Again, if you're interested in cluster API and MAAS, specifically how Palette can help provide an end-to-end experience managing the clusters, please do check out spectrocloud.com. And Joe runs the Atlanta Kubernetes group that hosts a monthly meetup that anybody can join to learn the latest and greatest about Kubernetes. More information is available at Joe's GitHub startup repo. Finally, our Twitter handles are all listed here. If you have any questions to any one of us, feel free to reach out. Thank you so much for watching, and a big thank you to our guests, Joe Searcy and Anton Smith. Thank you so much, team, and have a good day.
And thanks a lot for today, Saad, and thanks, Joe, and thanks everyone for coming along.
Thank you. Bye.
Thanks, everybody.
Cheers.